Hello again, happy Thursday if you're watching on Thursday. If not, then happy whatever day of the week you're watching on, I guess. Um, we are moving on to 8.2 today, and here's your bell ringer that covers some stuff from 8.1. So give it a try. All right, I won't take too long talking through this, but first thing I would do is take out some GCFs. All right, I can do that, and I can do that, and I can do that, and that. So let's see. 5 and 5 are gone. 2y minus 1, 2y minus 1 are gone. Y minus 3, y minus 3 are gone. Looks like 4/3. All right. All right, cool. If you want to do this one for practice, you can. I'm not going to talk through it, but if you want to pause it and give it a try, go for it. All right, answer's there. P/8. Sounds good. Okay. All right, so today is basically, I'm breaking 8.2 down into 3 separate lessons, right? So we're only going to do the first part here. It's basically focused around your LCM, right? Your least common multiple, which is something you've talked about in previous math courses, but not in the same way that we're going to do it now, okay? So first we're just going to start off with looking at monomials, right? Here are 3 monomials, right? There are a few different methods that you can use. You might have used some weird, like tic-tac-toe looking thing. I'm never into that stuff personally. I think on these you can sort of use some intuition to some degree, but 15, 16, and 20 are not necessarily numbers that that you have a lot of experience working with in terms of multiplying and whatnot. So I'm going to show you a method that's actually going to relate this to what we're going to do with it in a second, which is dealing with polynomials, right? Higher degrees. So the way to do that is we're going to break each term down into a prime factorization. All right, so I'll show you this here, and then I'm going to erase it in a second, right? But I would do a factor tree. I would say that's 3 and 5. And I would keep going from there, okay? You're going to basically do a prime factorization on all of those. Prime factorization means break it down as far as you can so that all you're left with is prime numbers. And if you do a factor tree and you do it all the way down, you don't stop where you still have, a 6 that could be broken down into a 2 or 3 or anything like that, then you're doing a prime factorization. You just might not have called it that in the past. So if you want to do a factor tree, you can do that, but I'm not going to take too much time in the video doing that. So 15a squared b c cubed is going to become 3 times 5, because that's how I get 15. And then the rest of it's basically going to stay the same, but I'm going to split up the variables. So we get that. 16b to the 5th c squared is 2. I'm going to write this as 2 to the 4th. Right, because it's 2 times 2 times 2 times 2 if you do a factor tree all the way down. So 2 to the 4th, I'm not going to write out 4 2's, and you'll see why. And then b to the 5th, and c squared. And then for 20, it's going to be 2 squared, and 5, and a cubed, and c to the 6th. If any of that seems weird, then do a factor tree and you'll agree with me. If you do a factor tree on 20, as far as you can go, you're going to get 2 2's and a 5 at the bottom of your factor tree. So that's what you end up with. So the key at this point, when you're looking for the least common multiple, is to take each number to the highest power that you see it. Okay? So for example, maybe I'll just start up here with the 3. Okay, so that would be 3 to the first power. If I look at all the rest of these, I do not see any other 3s. So I'll just divide right there. I need a 3. I need a 3 to the first power. That's the highest power that any 3 is raised to here. Then you go to your 5, right? Same situation. There's a 5 to the first power there. There's another 5 right there, but they're both just raised to the first power, so we only need it raised to the first power. And then if I look at my 2s, so this is where it's a little bit different. There's a 2 to the 4th. There's a 2 to the 2nd. And I want the highest degree, or the highest exponent, so I want 2 to the 4th power. You could even, if you want, as you go, cross some stuff off so that you can keep track of what you've already looked at. But you always want to do your numbers first, your coefficients. Now if we look at our a's, I see a squared and I see a cubed. I want the cubed because that's higher. So a cubed. So those can go away if you want. I see b to the 5th as my highest b. And then I see c to the 6th as my highest c. Once you take the highest one of each of them, you're going to multiply 3 times 5 times 2 to the 4th, right? 3 times 5 is 15. 2 to the 4th is 16. 15 times 16 is 240. So I'll just write it up here. 240 is what I get from my numbers. And then the variables are obviously easy at this point because there's nothing else going on. It's a cubed, b to the 5th, c to the 6th. That might seem like a lot, but it should reassure you that the variables are super easy because even if you go back to the original problem, you don't even have to write them out again in parentheses like I just did. If you look at the original problem, you see an a squared, no a in your second term, and then an a cubed. A cubed's higher than a squared, so you take an a cubed. You might have just heard my cat meow. She can be like that sometimes. I just don't want anyone to think that I'm like murdering Maria or anything like that. And then b's are, that's b to the 1st, b to the 5th, and then there's no b, so we want the highest one, which is b to the 5th, and then c to the 6th is the highest, so that's why we take that one. The only weird thing is your coefficients, right? But again, if you do a prime factorization and take the highest exponent for each, that's one way to do it. All right. Cool. And I do have another example on that, but I'm going to do this one first. The reason I showed the first example like that is because it uses factoring, which is what we're going to use on all of these, even though the factoring is going to look a little different. This first trinomial, first thing I can do is take out an x, right? I have a GCF of x, so that's going to leave me with x squared minus x minus 2. And I can factor that. The x is going to stay, because I can't do anything with that, but it needs to stay. And then this is going to be an x minus 2 and an x plus 1. That is that trinomial factored, right? It becomes these two. So now we're there. That's for the first one. And then for the second one, I should be able to factor it right away. It's just x minus 2 times x minus 2, or I should write this as x minus 2 squared. Now it's pretty much like the one we just did, right? I mean, you might not be able to see it yet, but if I look at each factor, there's a factor of x. It's the only one I have. So x to the first, I guess I need that. I'm not going to put it in parentheses. You'll see we don't need to. Then I look at my x minus 2. There's an x minus 2 squared. I want the higher one. I want x minus 2 squared. And then the only thing we're left with is this x plus 1, which we want as just x plus 1. I do not have to multiply those. They are fine just like that. or whatever order you choose to write them in. I would write that x out front because it would look weird anywhere else, but the other two orders do not matter. Yeah, you see they wrote it in a different order. That's fine. All right, on this one. So we'll do a little more practice with that factoring. 6 is 2 times 3. That would be your prime factorization of 6. And I'm not even going to write out, I don't know, I got a message up here, I don't know what the heck that's about. Don't show again. Okay. 9 is 3 squared. Yeah, I'm not going to write the variables out. I think you're hopefully seeing by now that they're pretty easy to get, but I'll show you that again in a second if you need to. And then 4 is 2 squared. I should probably write those in the parentheses. It doesn't matter in this case, but that's how I wrote them last time. Okay, so for my 2's, I see a 2, I see a 2 squared, so we're going to take 2 squared. And then for my 3's, I have a 3 and a 3 squared, so we want 3 squared. And again, that was the hard part, because if I look at my x's, going back to the original up here, I want the highest power I see on an x, which would be x cubed. I want the highest power I see on a y, which would be y cubed. And I want the highest power I see on a z, which would be z squared. Now all I got to do is simplify this. 2 squared's 4, 3 squared's 9, 4 times 9 is 36. So 36, x, oh, that's not a cube 3. That is not either. Oh boy, pressure's on. Oh, that we'll have to do. X cubed, y cubed, z squared. That is another 3. Oh boy, all over the place today. 36, x cubed, y cubed, z squared. Yeah, cool. All right, and then one more of these. So first step again is I see I can take an x out of that first one. X squared plus 2x minus 3. And then it's going to be able to factor to x plus 3x minus 1 with the x still out front that we pulled out as a GCF. And then this is x plus 3, or just x plus 3. I did it again, x plus 3 squared. So we need the x to the first power, we need the x plus 3 to the second power, because that's higher, and then we just need that x minus 1. So you need to write every factor at least to at least the power of 1, right? If a factor shows up, we need to include it in our answer. Right, you should be seeing that. And then we need to take the highest exponent of each factor. So if I have x plus 3 and x plus 3 squared, I want the x plus 3 squared. And again, the order does not matter too much. You do not need to multiply those out or anything else. All right, 8-2 huddle numbers 1, 2, 6. Boy, oh boy. All right, so you're looking at this. All that it's having you do is find the LCM. So some of these are a little bit trickier than the examples in the notes, but give them a try. I'll give you the answers and maybe explain if I can find anything to explain. Pause now. All right. So number 1 should be 12c squared d. 2 is 72 a cubed b squared c squared. 3 is 2, let's say 3 is 2 times x minus 3. I had it multiplied, but I don't want to confuse you. So 2 times 2 parentheses x minus 3. Sounds good. 4 is a weird one. It's 5a and a minus 1. Basically, neither of those can be factored at all. Nothing can happen there. So you take everything exactly once, because 5 is raised to the first power, a is to the first power, and a minus 1 is to the first power. So there you go. 5 is going to be t plus 5, t minus 5. And 6 is x minus 4, x plus 1. So both of those last two are kind of weird because the first term, or the first polynomial factored, was just the answer. But it's because the t plus 5 and the x plus 1 were already accounted for because of the factoring. Hopefully those went well. If they did, then you need to do these on your mastery, 1 to 9, but do not do number 6. Okay, I figured I'd skip one, and that one is sort of weird. You'll notice when you get to like number 5, maybe number 5 is the only one. Matter of fact, I'll just take off number 5 too. I won't throw anything in there that we didn't necessarily go over. I don't want to confuse you while you're away. Okay, so do those ones that are not in red. Maybe I'll just delete those. They'll be in your PDF, but that way you know what you're looking at. So that's your mastery, and then your homework is just those 5 questions from the book. Obviously, you can either use the online textbook, which I think is what most of you have probably used throughout the year, or if you happen to have your physical copy on you, you can use that as well. Okay. If for whatever reason you need help getting on the online book, if that is not something you've chosen to do up to this point and you're not familiar with it, then just let me know. We'll hook you up. Quiz tomorrow. I will not be, or you'll already have everything posted, but so there's not a lesson or anything else you need to do. All you got to worry about is the quiz. Have a good weekend, since I guess I won't be talking to you through video until next week. And keep me up to date on how everything's going. Let me know if you need me to change up how any of this is happening or anything like that. Okay, bye.